Picture this: a world where the sleek leather jacket you slip on each morning, the designer handbag slung over your shoulder, even the steering wheel of your electric car, none of it comes from animals or oil. Instead, it's grown in trays in a warehouse. Welcome to mushroom leather, an extraordinary material spun by nature's most humble recyclers, fungi, and poised to reshape the fashion industry forever. Why should you care? Because every year, over 1 billion cows are slaughtered for leather. Tanneries leach toxic chemicals into rivers, and plastic-based vegan leathers persist in landfills for centuries. But in the past decade, startups and scientists have unlocked Mycelium, the hidden, fibrous root network of mushrooms, as a regenerative alternative. In this film, we'll journey from the microscopic hyphae to high-end runways, meet the pioneers growing leather in bioreactors, and discover how what was once waste is now the next frontier of sustainable style. Leather valued for millennia for its durability, water resistance, and natural patina has hidden costs we can no longer ignore. Globally, cattle ranching occupies more land than any crop, driving deforestation in the Amazon and savannas. Producing just 1 kilogram of cow leather consumes over 20,000 liters of water, roughly what it takes to keep a person alive for 3 months. And then comes tanning, chromium salts, formaldehyde, and other heavy metals that transform the hide but pollute local waterways, poison ecosystems, and endanger tannery workers. Meanwhile, vegan leathers made from PVC or POO are petroleum derivatives. They avoid animal slaughter, but they shed microplastics, leach phthalates, and linger in landfills for centuries. In a world racing to curb emissions and plastic waste, neither solution is truly sustainable. That's why innovators are turning underground toward mycelium as a third path. Materials grown, not mined, reared, or sliced. At the heart of mushroom leather is mycelium, the root-like network through which fungi extract nutrients and communicate. Think of it as nature's 3D printer. Each microscopic hypha secretes enzymes that break down whatever it grows on wood chips, agricultural byproducts, even paper waste, and builds new cellular walls in concert with its neighbors. Under the right conditions, temperature, humidity, substrate composition, thousands of hyphae intertwine into a dense mat, with strength and flexibility rivaling traditional hides. Researchers at the University of Utrecht mapped mycelium's mechanical properties in 2015, finding its tensile strength approaches that of low-grade cow leather. By tweaking substrate grains, adding flax fibers here, cornstarch there, scientists can modify stiffness, thickness, and even surface texture. It's biomaterials engineering at its finest, directing an organism to fabricate a product tailored to human needs, all while sequestering carbon and upcycling waste. How do we go from a petri dish to a supple jacket sleeve? It starts with inoculation. A spore or small mycelium fragment is mixed into a sterilized substrate, often ag waste like hemp hurd, coffee grounds, or sawdust. That blend fills shallow trays inside a controlled growth chamber. Over 5–10 days, under filtered air and precise humidity, the mycelium colonizes the substrate, digesting and binding it into a coherent block. Next, that block is pressed between heated platens. Think giant panini press, which flattens the colonized mass into thin sheets, collapsing air pockets and enhancing fiber bonding. From there, the raw sheets are dried, trimmed, dyed using natural plant pigments or low-impact synthetic dyes, embossed with patterns, and treated with plant-based waxes or biopolymers for water resistance. The entire cycle takes under 2 weeks, compared to years for animal hides, and uses a fraction of the land, water, and energy. Several trailblazers are racing to commercialize mushroom leather. Bolt Threads introduced Milo in 2019, collaborating with Stella McCartney on limited edition bags, and Adidas on a prototype, Stan Smith Upper. MycoWorks, backed by LVMH and Kering, has patented its fine mycelium process to achieve customizable grain patterns and thicknesses. Think pebble grain handbags and luxury watch straps. Ecovative design, one of the earliest fungal innovators, supplies mycelium insulation and is now scaling into fashion prototypes. Beyond these names, dozens of boutique labs worldwide experiment with locally sourced substrates, from rice hulls in Thailand to olive pomace in Italy. Each yields subtly different textures and colors. The result, a library of mushroom leathers that can be fine-tuned for softness for apparel, stiffness for footwear soles, or even high-gloss finishes for luxury goods. Mushroom leather's environmental edge isn't just marketing life cycle. Analyses show dramatic wins. Compared to cowhide, it uses up to 90% less water, emits 80% fewer greenhouse gases, and transforms low-value ag waste into valuable material. No methane from burping cattle, no chromium-laden effluent, no slurry lagoons. But what about end of life? Unlike PVC or PU leathers that fragment into microplastics, mycelium sheets are fully compostable in industrial facilities and often even at home. Imagine tossing your old mushroom sling bag into a compost pile, where microbes and earthworms break it down in weeks, returning nutrients to soil. That circularity appeals to the next generation of conscious consumers and aligns with emerging regulations in the EU and California targeting single-use plastics and toxic tanneries. No material is without hurdles. Scaling from lab prototypes to ton-level production demands industrial-grade bioreactors, sterile chambers, big as shipping containers, with precise climate control and rigorous quality checks. Contamination by competing molds or bacteria can ruin entire batches. Also, current cost estimates place mushroom leather at $20, $50 per square foot, compared to $3, $10 for commodity cowhide. Achieving price parity will require automation, larger facilities, and process optimization, likely a 3-5 year horizon. Durability testing also continues, while lab tensile and abrasion metrics impress. Real-world performance over decades, how the material patinas, ages, or handles extreme weather remains under study. Startups are partnering with automotive and furniture firms to run accelerated aging tests, UV chambers, salt spray, flex cycles to ensure that what starts as a fungal novelty can mature into a trusted material. What do consumers think? A 2024 survey by Green Style Insights found 68% of Gen Z willing to pay a premium for truly sustainable materials, and 72% more likely to buy if the product is compostable. Early adopters rave about the soft leather feel and unique, non-plastic scent. Designers too see creative freedom. Dr. Stephanie Lin, head of R&D at a European handbag house, calls Mycelium a blank canvas. It can be laser cut into intricate patterns, embossed with custom motifs, and blended with other fibers like linen or silk for hybrid textiles. Storytelling matters too. Brands leveraging farm-to-closet narratives, showing fields of substrate, trays of growth, and hands finishing the sheets, build trust and emotional connection. In an era of fast fashion backlash, mushroom leather occupies the sweet spot of novelty, performance, and environmental responsibility. Mushroom leather is just the beginning of the fungal renaissance. Mycelium is being engineered into carbon-sequestering building materials, living bricks that grow and self-heal cracks. It's making vegan egg yolks in food tech, biofilters to purify air, and even computing substrates that conduct electricity. The same principles apply. Feed the mycelium the right inputs, guide its growth, and harvest a custom-designed biomaterial. That convergence of biology and design growing products instead of manufacturing them is part of a larger shift towards circular, regenerative economy. As we face climate emergencies and biodiversity loss, the question becomes, can humanity scale these biomimetic solutions in time? Mushroom leather offers a hopeful proof of concept. So, is mushroom leather the definitive future of fashion? It has clear advantages in sustainability, creativity, and circularity, but also hurdles in scale and cost. The next few years will reveal whether it can displace animal and plastic leathers at commercial scale. Either way, this humble fungus has burst out of the forest floor to challenge the foundational assumptions of material science. If you're a designer, entrepreneur, or curious consumer, now is the moment to explore, experiment, and advocate for products that respect the planet. Because every time we choose materials that sequester carbon, eliminate toxins, and cradle life's diversity, we move closer to a resilient, regenerative world, one mycelial thread at a time. Thank you for joining this deep dive into mushroom leather. If you found this illuminating, please like, comment your questions below, and subscribe. New documentaries soon.